let's do the MCQs for the data management system. We will start with 2024 and go backward, right? So each year about 25 question is there. So possibly we can finish all three subjects, all three past papers, okay? Uh, right, so let's straight away start from question number one. Uh, and this paper says only one correct answer. So therefore it's less time consuming, right? 2024 paper, it says only one answer. Right, so let's do one by one very quickly. Okay, let me close and open this. Right, question number one, we can do it very fast. Which type of polymorphism checks the object type during program execution? If it is program execution, that is called late binding or runtime polymorphism, right? Not early binding, late binding, or dynamic binding. So not static binding, not early binding. Dynamic binding, yes. Not compile time, runtime, not parallel binding. So the best answer is C, right? C. So that is from your programming knowledge, okay? From semester one. Right. Question number two. Which of the following statement is are true regarding encapsulation? That is, we for for a particular functionality, we take all attributes and behaviors and package into one unit called class. Right? All your attributes and behaviors are encapsulated into class. Right? True about encapsulation in object databases. Encapsulation binds together code and data it manipulate. So I hope code means methods. All right. So this is a little bit loose, but I hope code means method. So then method then data. So reasonably okay. Encapsulation requires all attributes of an object to be visible to the database users. No, you can have private attributes, right? You don't expose them, right? So not all objects attributes need to be visible to the database users. No, that is why we have private, public. Encapsulation restricts direct access to the object's hidden attributes and allow access only through predefined operations. Yes, that is called data hiding. Data hiding is a special case of encapsulation, right? So we'll take because it's also special case of encapsulation. So we'll go for 1 and 3. That is C. C. If you need more explanation, you need to tell me. Okay. But this look very simple paper. Which of the following statements is true regarding characteristics of a structured, semi-structured, and unstructured data? Right? So structured, semi-structured, unstructured. We have discussed those in the class. Structured data lacks predefined schema. No. Structured data has a predefined scheme. Okay, so therefore no. Semi-structured data follows strict schema. No, strict schema is for structured. And all the records share the same data structure, so that is structured, not semi-structured. Unstructured data has predefined schema. No, unstructured data doesn't have predefined schema. Right? I'll say no. Structured data is organized using database schema. Yes, structured data, we can put it into database schema, while unstructured data lacks schema information. Yes, unstructured data lacks schema information. So that is reasonably good done. Semi-structured data requires fixed attributes, names, and values for consistency. Semi-structured means you have the flexibility of different objects having different attributes. right? So that is why we go for something like column space databases, okay? Or XML type, JSON type, because we have more flexibility. I say no, not fixed attribute. Fixed attribute is structured. So therefore, I'll go for D. D. If you have any questions or if you don't agree or if you need any more clarification, right, let me know. Fourth one, consider the scenario given below. Imagine content management system called Doku Hub, designed to store diverse documents such as contracts, reports, multimedia files. Each document includes metadata like title, author, and tags. That means the document and metadata. Okay. The system needs flexible data model to support hierarchical and self-describing data structures. Right. So basically, it's going to keep data, documents. Right. It says like contact details, reports, multimedia. Right. Which of the following data store is most suitable for the above requirement? Document? Yes, possibly because these are documents. Key value? No, this is not for key value. These are reports, right? Documents, not graph. Graph is for like social media and that kind of things. Not column family because these are documents and definitely not relational, right? So the best answer for me is document. Okay. Yes, say. Which type of memory provide fastest data access but has the lowest capacity in the computer memory hierarchy? So that means the closest to the processor, either registries or maybe cache. Secondary storage, no, that is SSD hard disk. Tertiary storage, that is backup storage. Dynamic RAM, yes, fairly close, but let's see whether we have cache and uh, cache or registries. Static RAM, that is better than this because static RAM is cache memory. Magnetic disk is either secondary or tertiary. So therefore, the best here is static RAM because you don't have the registries here. So I'll go for D. 6. Which of the following index is more suitable to search a record based on the equality condition? So that means single result. For single results, we prefer hash. If you are looking for ranges or set of values, right, range, nearby range, like in ascending order, salary between 1 lakh to 2 lakh employees. So then we go for binary B plus tree. Okay. So reversible index, I don't know what is that. Hash, yes, because it says equality condition, right? Equal, say, uh, employee number equal this, so name equal this, right? So hash index is good, not bitmap index, right? Not clustering index, that is different concept. A function index is when your query also has something like a function like upper or something, right? So I'll go for hash, but that is the best for me. We discussed that in the yesterday class also, right? Revision. Yes, B. 7. Which database operation guarantees that all changes made during transactions are permanently recorded in the database? That is durability. Okay. After your transaction is committed, it must be persistent. Right. Rollback, no. Abort, no. Save point. Actually, save point means you save uh, different places so that you can roll back up to that point. Okay. So that is also somewhat okay, but let's see whether there's something like commit or something. Okay. Right. Revert means you basically abort. Yes, commit is there. Right. So save point is also okay, but commit is the best answer. Okay. Commit is the best answer. That means your data is flushed to the database permanent. Right. So we'll go for E. E. 8. For question 8 and 9, consider the following SQL statement that creates the book relation for answering question 8 and 9. Right, so it's a table called book. Book ID is primary key, int. By default, it is not null. Title Vacha not null. Author Vacha 100 not null. Publisher int, and there's a check constraint for the publisher year. Publisher year must be greater than or equal to 1900, and publisher year less than or equal to 2020. That means between 1900 and 2024. Price, it's a decimal with 2 decimal points, total 10. And there's a check constraint, price must be greater than 0. And ISBN is Vacha 30. Okay. Right. Which of the following statement is true regarding constraint violations in the book relation? So there are insert statements. So which of these insert may not work? Okay. Or which of these insert will work or accepted by database? Right. Insert. Here you can see there are no, it's just the values. Field names are not given. So then you must follow the same sequence, right? So then this must be book ID. Yes, 1. Assume 1 is already not there. So this is not null, right? Grade. This is Vacha 100, less than 100. So this is less than 100. Another Vacha. Publisher year, it says 1925. 1925 is between 19 and 2024, right? 1900 and 2024. Yes, that is also fine. Uh, Price must be bigger than 0. Yes, that is fine. 2 decimal places. Otherwise, it will be truncated. ISBN Vacha 13. Yeah, that is also fine. Look at the syntax, insert into. Uh, I don't know whether we use this one, but all the answers use this less than greater than. But usually you don't need less than greater than, right? Because it's bracket. But because if you take that as wrong, actually there won't be any answer. Okay, so therefore I will ignore that because that is a notation used in all. Right, so it looks okay if you ignore that because everywhere you see this. What about this insert 3 to kill a mock? Right, it says violate the domain constraint, right? I don't think it violate domain constraint, right? It looks okay. So therefore it's wrong actually. Second one, find, null, no, because remember it's a not null, all are not null fields. Only the publisher here is, sorry, author is not null. That is third field is not null, but here it's null. That is not going to work. And it says violate key constraint, not the key constraint, that null constraint. So therefore that is wrong. Uh, this says has no violations. Okay, let's see. That is fine. This is fine. This is fine. 1800. No, it's not going to work because it must be bigger than 1900. But this says no violation. So therefore I'll say no. D, obviously null will not be accepted by primary key. Then this must be okay, correct. For 1984, but it's a valid Vacha. Maybe its title is 1984, right? So then this is fine. 1949, is it within this? Yes, 1949 is within this. Then price must be greater than 0. This is not greater than 0. Okay. Uh, so therefore it won't, but it says referential constraint, right? This is not a referential constraint violation. So that is also wrong. So then I think we have missed something. Can anyone detect? Because there should be at least one answer, right? Key constraint. No, it's not a key constraint. This is definitely wrong. Uh, Domain constraint.
So isn't first one correct?
What
A
is
part.
what is the first? That is what I'm also asking. What is the issue?
There is no. Uh,
Which domain constraint is violated? Primary key is fine. Title is fine. Author is fine. Publisher year is fine. Uh, price is fine because this is the maximum. 10 and 2 is maximum. And it is bigger than 0.
so
Oh,
what is that 10 and 2 mean?
sorry?
What does that 10 and 2 mean?
That is total width and number of decimal places. Maximum. Maximum decimal places 2. Maximum width 10 digits. This looks violate domain constraint. Therefore, I'll say no. It doesn't. I don't see any violation. Let's see the C. 3, fine, fine. 1800 is not going to work because 1800 is not bigger than 1900. So therefore, this is also wrong. This is definitely wrong because you can't insert null to primary key. But what is a referential constraint? But referential constraint means foreign key related thing, right? Where do we have referential constraint?
No, I think D is correct.
Sorry, E is correct. What is the referential
D,
constraint
D,
that,
D.
huh? D.
It's integrity constraint. It violates. So primary key is not. So it violates it.
It says entity integrity. Sorry. Yes. Right? Yeah. So it's not, I just check whether this insert statement is wrong. Yes, insert state. Yeah. So therefore, this is anyway wrong because no referential integrity violation. Yes. So this SQL statement is wrong, right? But I just thought, okay, that is wrong. But anyway, it says that it violate entity integrity constraint. Yes. So if you insert a null value to the primary key, that means you violate entity integrity constraint. Yes, I didn't read it actually. Okay, it's my mistake. So this is perfectly correct. If you try to insert null value or duplicate value to the primary key, it results in entity integrity constraint. Yes, we discussed that. Okay. Yes, I just look at the SQL statement and say it's wrong, but actually I should have read entire statement, right? Yeah, therefore the explanation is correct. Right. So the definitely answer must be D. Yes. Yes, answer is D. Okay. Right. Ninth question, is it related to this? Yes. That is also related. Which of the following SQL statements create an assertion to ensure that ISBN column in the book relation doesn't contain any null value? That means ISBN must be not null. Now here it has not specified that not null. Now you want to enforce it through a assertion, right? Assertion. So you remember assertions almost all the time involve exist or not exist. Okay, right. Create assertion, right? Just a name. I think that part is everywhere, right? Create assertion. This any name you can give. Create assertion name. Right? Check part is not in the assertion, so that part looks okay, right? Create assertion. Create assertion. Create assertion. Okay, right. So then check. We want to make sure that ISBN is not null. Okay, at any time. Check not exist. Select all from book where ISBN null. So that means if you write a select statement uh, to get any books with ISBN null, you should not, that kind of a thing should not exist. right? So that is correct, right? So ISBN null records must not exist. Check whether ISBN null records not exist. But not exist is not a violation, right? Violation is exist. So, but this says not exist, right? So not exist is not the violation, right? So therefore, it must be not exist. It must be exist. If exist, select all from the books where ISBN is null, so that violate. So therefore, I will not take this because it says not. Okay, it says not. What about this exist? Select all from book where ISBN is not null. So that means it check whether there exist any records with uh, ISBN not null. No, that is not correct. Right? Either exist ISBN null or not exist ISBN. Uh, check whether ISBN null records are there, then it's valid. Okay, so therefore this is also not correct. This one check, but there's no exist here. Okay, there's no exist statement, so therefore I will not take that. Okay. What about this? Check not exist. Select all from book where ISBN greater than or equal to 0 is not exist or not, right? So I'll say no. Uh, exist. Select count ISBN from book. No, right? That is not. That means definitely the last two are anyway wrong. Now let's again check the first three. ISBN not now. Check. Select all from book where ISBN is greater than or equal to 0. No, not greater than or equal to 0. We need to check for null. So therefore, this is definitely wrong. This is definitely wrong. And this is, no, I select count ISBN. That means whether records exist, right? No, that is not going to work.
So I think D is correct.
Which one?
D.
D? But it
Yes,
says
sir.
ISBN greater than or equal to 0, right? Not book.
Not exist.
But that is, we are supposed to check for the null, right? Not greater than or equal to 0, right? We are supposed to check the null, not whether it's greater than or then what happens if we have someone has added minus number? Because ISBN, of course, it may not be domain-wise correct, but right, we are supposed to check null values, right? Not greater than 0 or whatever. I'll again let's double check again A and B. Not exist. Select all from book where ISBN is null. But not exist means it's okay. This must be a violation. What about next? Select all from book where ISBN is not null. That means not null, uh, not null records exist. If not null record exists, that is not a violation, right? So here null records not
So they
exist.
have said does not contain any null values. No?
Yeah, so that we need to make sure. If assertion means we need to make sure that if there's a null value, this statement is violated, right? That is why we need to check it. So, no, sorry. This statement must be satisfied, right? Yes. I check.
Yes, sir.
Yeah, we need to check whether this satisfied, right? Anyway, I will not go for CDE. So then again, let's look at like that. So whether this statement is satisfied, not exist, select all from book where ISBN is null, but that then it should be exist. No, right? Not exist. All right, this is okay, right? So we want to check whether ISBN null records not exist, right? All right, then this is okay, right? So we want to check whether uh, No, right? Check whether not exist or exists. So this is exists not null records. Select all from book where ISBN is not null, but that is not null record exists, right? This can't be the issue because exists means at least one. I think then A is correct, right? So that means we need to check whether null record not exists, right? Check whether null record not exists. But if it exists, this is violated, right? If there's at least one null record, then this statement will give uh, a record. So that means exist is true. Then not exist will be false. Not exist will be false means this is violated, right? Yeah, I think then A, right? So then it should be A. What is the examiner's answer? Yeah, A. Yeah. So we need to check whether this particular condition satis, right? So if this condition is not satis, that operation is aborted. For example, now say we insert a record with null. Now then what happened? Select all from book where ISBN is null is true. That means it exists. Exists true means not exists false. So that means this violate. So that if the moment it violate, this assertion will give you error, right? So answer is A, correct. Okay, answer is A. Okay, right, because we want to make sure that this condition satisfies. But if you insert a null value record, this condition will violate, right? It will be violated. So then it won't allow that operation to be done. So therefore, yes, answer is A. So the last three are not correct because it's not what they are. You are supposed to check whether it's null, but you are checking whether it's greater than no, greater than zero, something like that. That is not. That is different check. Right? Yeah. Answer must be A. Okay. Answer must be A. 10. Consider the following SQL statement used to create host relation. Uh, the host relation references coordinator relation through a foreign key. Right. So, yeah, you can see references coordinator. Coordinator ID is the foreign key. Right. Coordinator ID is the foreign key that refer to the coordinator table. But this is host table. Host ID is the primary key. Right. It's implicitly not null. Host name is Vacha 100, not null. Coordinator ID is int and it's referred to the coordinator table's primary key called coordinator ID. And we have on update and on delete. Okay. For the foreign key. The following requirement must be met for the referential actions. Updating coordinator ID in the coordinator table relation should automatically update the corresponding coordinate ID in the course relation. That means up on update cascade. Right? Cascade. Deleting coordinate ID in the coordinator relation should be prohibited. That means restrict. Right? If there are corresponding records in the course relation. So that means on delete restrict. Right? Restrict. On update cascade. Okay. Right. So therefore, first one is on delete, second one is on update. So that means restrict, comma, cascade. Restrict, comma, cascade. Okay, so that is straightforward. 10, it must be C. Yes, C. 11. Which of the following statement is true regarding primary file organization? Primary file. What is primary file? Maybe database system. Okay, primary file organization. Right, let's read. Heap files stores record in no particular order. Yes, heap means you just add the next record, next record, next record to the end. Okay, heap means that. Right, so there are three type of files. Heap file, that means you just add the new record to the end. You don't care about any order or whatever. Then sorted file, where you always maintain sorting order. That means you enter the record to the correct place so that always sorting order is maintained. In sequential file, uh, where you add it to the end, but you preserve the primary key order, right? Primary key order. So usually the sorted records are maintained in some other sorting order. Okay. But heap means you just add to the end, no sorting order, nothing. This is the simplest, but because there are no order, update, delete will be slow. Insert will be fast because you just add it to the end. Okay. That is called heap file. Heap කියන්නේ ගොඩක්, දර ගොඩක් කියලා කියන්නේ දර ගොඩක් ඔය නිකන් උඩින් දානවා අගට. Heap files store records in no particular order, yes, and append new records at the end. That is exactly what heap file. Sorted files maintain an order for records based on the values of a specific field. Yes, that is what is meant by sorted file. Okay. Hash files use hash function to determine the placement of the record in the database. Yes. So if your hash field is employee number, you give the employee number to the hash function and it will give you the hash value, which is if you have 100 blocks, one of the blocks. Right? So it will randomly spread your records. So that is correct. Okay. Hash file. I'll go for all. Yes, answer is all. Okay. 12. Right. So that's a calculation question, right? So let's draw it. A file contains 200,000 employee records. Right? 200,000 employee records, each with fixed record size of 120 bytes. 120 bytes. The block size of the disk is 1024 bytes. Block size is 1024 bytes. Calculate the block factor and the number of blocks required to store the file, assuming it is unspanned organization. Right? That is typical question, right? So what is the block factor? BFR, number of records in a block. So that is block size. That is 1024 divided by size of one record. That is 120 bytes. Right, I will be using my calculator, but I think in the check whether in the exams you can use it or not. Otherwise, you need to do the normal way. 1024 divided by 120 number of records. 8.53 means you can keep only 8 records because you can't keep fraction of a record. And again, it says unspanned also. So block factor is 8. So therefore, these are not correct. So then number of blocks required. So number of blocks required is we have 200,000 records and each block you can keep 8. Divide by 8. So that is 50,000. That is 25,000. Right? 25,000. 8 blocks, 25,000. I'll go for B. Right? B. Yes, B. 13. Right, let me close and open because when I write, there's a flickering. Right, 13. Which of the following statement is true regarding indexing in database? Indexing. The primary index is created on an ordered file using ordering non-key field. No. Primary index is if you have ordered by primary key. No. Secondary index can be created only on non-key fields. No, right? For example, if you don't have primary index, rather you have a how do you call it, clustering index, then your secondary index can be on primary key field as well, right? So there's no rule saying your secondary index is only for non-key fields. Sometimes your secondary index is for the primary key because you have used clustering index. Okay. So I will not. I explained that in yesterday class also, right? Primary index is created on the ordered file using the ordering key field. Correct, right? So your data file is ordered by key field, and now you have secondary index file for primary key. Okay, so it looks okay. Let's see the other two. Clustering index is used when multiple records have the same value for the non-ordering field. No, that is not the definition of clustering index. Clustering index is your data file is ordered by field other than primary key, and then you have index file for that. Okay. So therefore, this is definitely wrong. It doesn't say multiple records have same value. A secondary index should be created only on the ordering key field. Secondary index ordering key field, no, right? Not only for, right? It can be for any other field. Your secondary index, you can do it for any field, right? So then I have the best answer is C. I'll go for C. Yes, C. 14. Which of the following statements is are true regarding data replications in distributed database system? Replication, that is duplication of data. Full replication, that means the full copy is replicated in all the sites. Full replication stores copy of the entire database at every node. Yes. The drawback of full replication is the degradation of write performance. Yes, because you need to write to each and every node, right? Each and every node, if there are 10 clusters, you need to write to all 10. Maybe we can make it propagate to the clusters, but still at the end, you must write it everywhere. So it's a write performance degradation, right? Rather than you write it one place, you write so many places. Partial replication balances availability. Remember, replication is for availability. And update performance, update means write performance. Remember, if you go for full replication, it degrades write or update performance. But if you have partial replication, that means some parts are replicated, some parts are not replicated. That is a compromisation, right? So you have reasonable availability and reasonable write performance or update performance. So I say all are correct, right? E. Yes. 15. Which of the following statement is true regarding the characteristics of NoSQL databases in the context of a distributed system? Right? NoSQL databases in the context of a distributed system, right? It's a distributed database, but you use NoSQL databases in the nodes, okay? True. Shredding is not applicable to NoSQL systems. Of course, you can do, right? That physically you break it into different sides. Some like horizontal or vertical. Some parts in here,
What
some
is
parts.
sharding?
That is we discussed yesterday, right? That is physically distributed to different places. Okay. So that can be done for any database. So it says not applicable, so therefore I'll say no. NoSQL databases do not support horizontal scalability. Of course, yes, right? Horizontal, vertical, you can do it. So, say Sri Lankan related records in Sri Lankan node, China related records in China node, in cloud. So we can break it into horizontal. Right? Which says do not, I'll say no. NoSQL databases only support structured data. No. Actually, NoSQL databases more support unstructured, semi-structured. If it is structured data, we can go for relational databases, right? It says only support structured data. That is definitely no. Immediate consistency is preferred over eventual consistency in NoSQL databases. No, it's NoSQL databases. What we need is eventual consistency, right? Not the immediate consistency. Immediate consistency is demanded by relational databases. So then definitely final one must be answer, right? Combination of sharding and replication improves load balancing, yes, right? Because you break it into different nodes and data availability. Yes, replication will make sure that in NoSQL databases, right? So this is this and that is that. So that is correct, right? So the sharding will make it load balancing because some records go to node A, some nodes go to node B, and so on. And replication will improve the availability. So you need to select the good amount of replication as well. So I'll go for you. Yes, C. Okay. At 16, which of the following statement is true regarding acid properties in transaction, right? Acid stands for atomicity, consistency, isolation, and durability, right? We have discussed that. You can refer to the recordings of those sessions. Isolation ensure that transactions are not concurrently executed. No, that is not the case, right? Actually, we want concurrent execution. At the same time, acid properties are preserved. Okay, if you don't allow concurrent execution, that means it's very slow. So isolation is not that will not prevent two transactions being executed parallel. No, actually, we are going to mix it. That is why we have the schedules. But isolation will ensure that no undesirable effects are uh, done. So that is why there's a control, right? There's a control. Control concurrent execution. So therefore I'll say no, because it says not concurrent. Atomicity ensures that the partial results of a transactions are recorded in the database. Not partial results are recorded. Atomicity means transaction is the smallest unit of success or failure. Right? So this is something else, right? Partial results of the transactions are recorded. So atomicity makes sure that your transaction is success as a whole or fail as a whole. This explanation is not like that for me. Consistency guarantees that the database state will transition from one valid state to another valid state. Yes, before the transaction, if the database is valid in business rule wise, after the transaction also it must be valid. Right? So that is, I'll say yes. So I'll go for B. Yes, B. Okay. Right. 17. Consider the following schedule S1, which consists of three transactions T1, T2, and T3. The data items are X and Y. Is it Note that each RIWI denotes read and write operation belonging to a transaction TI. That means R1 means read by transaction 1. Which one of the following precedence graph correctly represent, right? So that's a typical question, right? That is typical question. We have done these kind of things, right? Right. So let's put it into something more readable. How many transaction? R2, R3. Say T1, T2, T3. Read X, uh, write X, write X, read Y, write Y, read 1 Z, read 2 Z, read Z, then second transaction read Z. Read 1 Z, read 2 Z. So then,
Sir, your device battery low.
okay, I'll connect it. Okay, thank you. Right, so let me use the other pen because it's flickering. Right, so just give me 1 minute. I'm waiting for the pen. Right, R reset. So then R1Y, R2X. I think I'm running out of space. Okay, just give me 1 minute. Okay, I need more space. Let me plug in my power also. Sorry for that. I think we need lengthier space than this. Okay, let me erase this. Right, so let's do it from the beginning. We need more space. Right, T1, T2, T3. T1, T2, T3. Read X, write X. Read X, write X. Read 2Y, read Y, write 2Y. Write Y, read 1Z, read Z. Read 2Z, read Z. Read 1Y, that is read Y. Read 2X, write 1Y, that is write Y. Read 3Y, that is read Y and write Y. So here we have read Y, write Y. Okay, last. Read Y, write Y. That is last one. Okay, read Y, write Y. Right, so there's a write, read, sorry, X. Do we have X again? Yes, this is read X, this is write X. That is T1 to T2. T1 to T2. Right, write X to read X. T1 to T2. Then here, no, here we have only Y. So X is not referred anywhere else. So then read Y, no, we have write Y. Read Y, write Y, that is T2 to T1. T2 to T1. Okay. Write Y. Anyway, that is T2 to T1 already we know. Right. So then we have treat Y in the T3. Here write Y. That is T2 to T3. T2 to T3. So this is read DZ and this is read DZ. So read D is not issue, right? ZD is only two places. This is also read. This is also read. Nowhere else we have Z. So read D is not a conflict. So therefore no issue there. Okay, no issue there. Do we have anything else? Anything else? Here we have read Y, write Y. There's T1 to T3 also, right? T1 write Y, T3 read Y and write Y. Yes, T1 to T3. There's another one, T1 to T3. Okay, right. I think
So
that's
can't we take that as T3 to T1?
no, T3 happens
Will
after
it be wrong?
T1. Sorry, it's time sequence, right?
If we take
T3,
T3 to T,
no, it's first
if we take
T1.
T3 to T1, then it is wrong.
No, what is your question? It's not clear. Why you think that it is T3 to
So
T1?
if no other way, if we take, will it be wrong?
Yes, you need to think this as a time sequence, right? Schedule is time sequence. So first T1
Okay, sir.
right, so then T3 right. So it's T1 to T3, right? T1 to T. This all the whole thing is a schedule. Schedule means time sequence, right? It's T1 to T3. So do we have this T1 to T3? So this is T3 to T1. Yes, T1 to T3, but this is wrong. T1 to T3 correct. T2 to T3. T1 to T3, T2 to T3, right? E is the answer, right? Answer is E. Right, so we'll go for E. Yes, answer is C, okay? Right, so when you extract this like this, it's easier, right? Actually, I ran out of spaces that otherwise you take a blank sheet and do it, okay? Right, so that is 17th question. Right, 18th. Right, it's a trigger question. Yeah, trigger question. Consider the following database. First, read the question. Which of the following SQL statement create a trigger to update total received amount attribute in order relation, uh, after payment amount is inserted into payment relation? So that means when payment amount is inserted or record is inserted to the payment, you need to update the total received amount in the order table. Okay, so therefore this trigger must be written for payment table. Okay, payment table. Uh, because when the payment table is added a record, insert a record, uh, order tables, total received amount must be updated. That means it must be added with the new payment amount, right? Payment amount. Okay. Right, so let's read. Consider the following database schema: two relations, order and payment, related to the wholesale shop. Payment can be made in multiple installments for particular. That means these are the multiple installments, right, for that order. So therefore, that is, if you have two payments, now you must have the first payment 1,000, second payment 500, then total received payment must be 1,500, right? Payments can be made in multiple installments for a particular wholesale order. Primary keys are underlined and foreign keys are italicized. So foreign key must be customer ID for the customer table, the order ID for the order table. We are more interested in this order ID. Right. Which of the following SQL statement creates trigger to update the total received amount, right? Total received amount, attribute of the order relation after payment amount is inserted into payment relation. So it must be insert after insert trigger, right? After, right? Create trigger. Update total received. Okay, let's read this first. Create trigger update total received after insert on order, correct? After insert on order for each row, correct? Begin and end. Actually, they should have written it in a nice manner, right? Anyway, begin and end is there. Update order, correct? Set total received amount equal total received amount plus new payment amount, correct? New payment amount, where order ID equal new order ID. It looks okay for me, right? After insert on order for each row begin and its update statement, set the total amount equal total amount. Here you don't need to set new or old or whatever because this is other table. But here new payment amount where order ID equal new order ID, right? So you're adding the new payment amount to the current total received amount. It looks okay for me, right? But let's check all the others. Create trigger update total received after insert on payment. Yes, it must be after insert on payment, not order. Right, sorry, it's my mistake, right? Because the trigger must be written for the payment, right? After insert on payment. So this is wrong actually. After insert on payment, for each row begin update order, set total received equal total received plus new payment amount, correct? Where order ID equal new. This is correct. Actually, this is wrong, right? This on order. Trigger must be for payment, right? When payment is done. Yes, you update the order, but trigger must be on payment, right? Payment records. So therefore, I'll go for B, not A. But let's see if there are issues we may find here. Create trigger update total received before insert, not before insert. It must be after insert because it clearly says after insert, right? Create trigger update after insert on payment, correct? For each row begin, correct, and end. Insert, no, not insert into order. It must be update order. Create trigger update total received before insert. No, not before insert, after insert on payment. So therefore, I'll definitely go for B. Okay. Right. 18, I'll go for B. Yes, answer is B. Right. So you must know exactly to which table you write this trigger, for which event, for which event. And of course, maybe you are doing update to another table, but trigger is for the payment. You update order table, but your trigger is for the payment. Okay. Right. 19th. It looks like index concept, index question, right? Yes. A data file contains, okay, Rohit. Data file contains 400,000 records with fixed record length of 200 byte. 200 byte stored in an unspanned organization. Unspanned, right? The records are ordered by non-key field with 1,000 distinct values. Okay. So that means, remember that yesterday we had a bit of confusion. So if either you go for one per uh, block, or we can go for, if they have distinct values, we can go for one record per each distinct value, right? So we'll go for that. This is probably secondary index. Okay. The block size is 4096. So one block is 4096 byte. And single level index is created on the ordering of non-key field. This is clustering index, right? Not a secondary index. Okay. The block size is blah blah blah. A single level index is created on the ordering non-key field. Yeah. Each index entry is 14 bytes. Right, so let's draw the index table now. Each index entry is 14 byte long. Calculate the number of block access required to perform the binary search only in the index file. That means you don't need the additional data file access. How many access in the index file only, right? You can see bold binary search only in index file. So that means you need to find out how many blocks are required, right? How many blocks are required? Because this is the non-key field, and we can say that it's if there are 1,000 distinct values, we have 1,000 records, right? 1,000 record. Here also the block size is the same this 4,096. Okay, so therefore we can look block factor here. You don't need to think about the block factor here now, because we are not interested in number of blocks here. Okay, we go by the one record for one distinct value concept. Okay, so therefore block factor for this one is BFR, because we need to calculate number of blocks. That is number of records in a block. Block size is 4,096. One record is 14. Right, I will use calculator. 4,096 divided by 14. 292.57 record means we need to floor it 292 records. 292 records. When you floor it, 292 records. Okay. So that means one block can have 292 records, but we have 1,000 records because one record for each distinct value. So the number of blocks for the index files is 1,000 divided by 292. But this time you need to floor it, because if you need 12.3 blocks, that means 13 blocks. So 1,000 divided by
So we need to seal it.
sorry, seal it. Yes, seal it. Because 12.5, 12.3 block means 13 block. Right. So let's divide 1,000 by 292. 1,000 by 292. That is 3 point something. That is, we need 4 blocks. 3 point something means we need 4 blocks for the index file. So now we can do a binary search here for that non-key field. So therefore log 24 is the maximum number of access required. Right, log 24, because 4 blocks. Log 24 is 4 is 2 to the power 2. You need 2 access, maximum 2 access plus 1, that is access in the block. But this question says only in index file. So only in index file, maximum you need 2, right? 2 blocks access. I'll go for 2. You need not calculate block factor here because we are not going for entry per block, rather entry per distinct value. Okay, because it's sorted by that field. Okay. Because that additional information is available. Let's see the examiner's answer 19. Yes, answer is B. Okay, answer is B. We did similar question in one of the second paper question. Okay, yesterday. At 20. Which of the following statement is true regarding the distributed database concepts? Right, this is about distributed databases. Replication, transparency ensure that, remember transparency means we don't care. It's handled by the DBMS, okay? Replication transparency ensure that the user is unaware of the data being replicated, correct? across the nodes in distributed database systems. Yes. Actually, user is sort of a yes, unaware. User don't care. It's hidden. So remember, transparent means hidden in IT terminology. Okay. So therefore, yes, it's sort of a unaware. We don't care. Okay. Users don't care. Users means the developers. When they write SQL statement, they don't need to worry about the replication. But that looks okay. Anyway, let's see whether there are better answers. Distributed database must always use the same hardware and software across node. You can have heterogeneous distributed database systems. Horizontal scalability, that means you can introduce new nodes, refers to increase in the storage capacity of existing node. No, that is vertical scalability. Partition tolerance means the system cannot function if network partitions occur. No. Partition tolerance means when a partition fails, still other partitions can operate. So this says cannot. No. Execution autonomy refers the independence of each node. Yes, independence of each node in terms of data model usage and transaction management techniques. Right. Execution of autonomy refers to the independence of each node, correct, in terms of data model usage and transaction management technique, right? It's not data model usage, it's how the queries are executed, right? But this says data model usage. Transaction management technique. It's not very wrong, but because I have a better answer, I will say this is not very clear. Okay, because it should be something to do with execution rather than data model. Okay, usages. So anyway, I'll go for A because I feel like A is better answer anyway. Okay, if A is not there, maybe I'll take E, but I will take A because A is much clear, solid answer for me. Right? What is examiner's answer? Yes, examiner's answer is A. Okay. Right, 21. Which of the following statement is a false regarding query processing and optimization in distributed database systems? Local query optimization focuses on minimizing the data transfer cost between nodes. No, that is not local. Local query optimization concern about that node, right? This is global, right? Transfer between nodes is not a local thing, right? I would say no. Query localization involves mapping a global query into subqueries based on data fragmentations and distributions. It looks okay, right? So you need to convert your global query into local subqueries, right? Depending on the data fragmentations and so on. I would say yes. Local query optimization is performed at each node, correct? And uses techniques similar to centralized systems. Yes, once you break it into local queries, it is like a centralized system for that node. I'll say yes. I'll go for 2 and 3. Right? I'll go for D.
So they have asked the false one.
They have asked, sorry, they have asked false one, therefore I'll go for 1. Okay. Yeah. Yeah. Anyway, answer is 1, yes. So they have asked for the false one, not the correct one. So therefore answer must be A, because A is the false one. Okay. Yeah. Sorry for that. Right. 22. Consider the student table given below. Student ID is the primary key. Student name, age, city, specialization, GPA. Uh, which of the following relational algebraic expressions is used to represent horizontal fragmentation of the above scenario? Right. So this is the table. It should be easy question. The database administrator wanted the student table to be fragmented based on following rules. Fragment the student relation into 2 sub-relations so that students' personal information will be stored in personal info right? Personal info table and academic details in academic info table. That must be a vertical fragmentation. Okay, that must be a vertical fragmentation. Fragment the student relation into two sub-relations, computer science students and information system students, based on specialization of the students. So that must be a vertical uh, fragmentation. But the question related to the horizontal fragmentation, right? Horizontal fragmentation. Or are they referring to both? I think they are only interested in horizontal fragmentation. Okay. Right. So computer science students, information system students. Personal info, academic info. Personal info, academic info is vertical fragmentation, right? I will not take B. I will not take C because we are referring to the horizontal fragmentation, right? Horizontal means you take like this, some records to this, other records to that. This must be based on sigma, right? So this can't be 5 for horizontal fragmentation. There are 5 take A out. Here also you can see 5. So definitely there must be sigma, horizontal fragmentation, right? Now just I need to double check D. Sigma specialization computer science from student. Sigma specialization, yes, this is the answer. Right. Right. 22, because question is only related to horizontal. I'll go for D. 22, I'll go for D. Yes, D. 23. Consider the following 5 schedules based on 3 transactions T1, T2, and T3 using read and write operations on data items A and B. Note that each RI, WI, CI, and AI, what is AI? Read, write, they explain. Read, write, commit is also there. And abort operations. There are abort operations also. That should be interesting one. Belonging to the transaction TI respectively. Which of the following schedule is recoverable? Right? Recoverable means if one transaction rollback or abort, uh, other transactions must also be recovered. Oh, that means cascade uh, rollback, right? So when A rollback, maybe we need to roll back B also, but still it must be recovered. Remember, this is related to dirty reads. Say first transaction write something, second
So what
transaction
is recoverable?
recoverable means you can recover it, right? You don't ended up in a situation where you can't do anything. That is called recoverable, right? So say now this is recoverability is related to uh, dirty reads. Now first transaction write something, second transaction read it, right? So then what happens if first transaction abort because this dirty read value is now not correct. When first transaction abort, the second transaction must also be aborted. So that is you recover it, right? Recovery. But But what happens is if this one write it and this one read it, and if this one has already committed, now when this is aborted, now you can't do anything. Now you can't recover it because this transaction is already committed. So that is where the schedule is not recoverable. So that is bad because there's a possibility of a transaction being aborted or rolled back. So therefore, if a transaction does dirty reads, it must make sure that it commits only after the other transaction is commit or roll back. So then you can recover this. Recover means cascade rollback. But if this transaction commit before this one, that is very risky thing. Not recoverable because by the time this is aborted or rollback, this transaction has already committed. So you need to check that scenario. Okay. Right. So you can see this is transaction 1 has written to A. Now transaction 2 read it. That is dirty read. This is a dirty read, right? Transaction 1 write, transaction 2 read. Then definitely transaction 2 must be committed after transaction 1, right? Transaction 2 must be committed. Now you can see transaction 2 commit before transaction 1 commit, which is bad, but there's no abort. If there's no abort, that is fine, but the risk is still there, right? Ideally, C2 must be after C1, right? But there's no abort, so therefore this is okay as long as no aborts. But this is very risky because we never know whether aborts can happen, right? So therefore, I'll just keep it question mark. If no answer, I will take this, okay? Because this is okay, but very only for this scenario. If there's abortion or uh, rollback, we are in trouble, right? What about B? Uh, this is B. This is read day. Read day is a dirty read because transaction 1 has written it and transaction 2 read it. So then definitely transaction 2 must be committed only after transaction 1. Right here you can see transaction 1 is committed. Sorry, 2 is committed first, then C1 is committed. This is again risky. Right? This is risky. Right? So therefore I'll say again question mark because no abortions, no rollback, but still this is risky. Anyway, what is the question? Which of the following schedule is recoverable? Right? So I don't think these are recoverable. Though there is no rollback, rollback can happen at any time, right? But let's see whether rollback is specifically mentioned somewhere. Right. So what about this? Read 1A, write 1A, read 2A. So this is dirty read. Second transaction read something first transaction has written. Okay. So therefore, definitely, uh, second transaction must be committed after first transaction. Okay. So here clearly second transaction is committed after first transaction. So that is good. That is good. Right. So then if there's issue with transaction 1, that means though we call it commit, it can be rolled back at this point. So then we can roll back take a second transaction because our commit sequence is after committing the first one. If first one roll back, we can roll back second one. This is recoverable. So I like this answer. Okay. But it's anyway it says commit. So therefore someone will say, okay, then nothing to recover, right? Anyway, so this is better answer than these two. Okay, because I now I have better answer, but still question mark because there's no specific uh, uh, abort. Okay, right. What about this? This is read 1A, write 1A, read 1B. Now second transaction read what the first transaction has written. So therefore, uh, definitely second transaction must be committed after first transaction. But here second transaction has committed and first transaction has aborted. This is really issue. Now this is definitely not recoverable. Okay, so this is definitely not recoverable because by the time the first transaction is reversed, so abort first second transaction has already committed and second transaction has already read dirty value. Now this read is wrong. Right. What about D? Read to write to, that is second transaction read, second transaction write. Now first transaction read. What the second transaction write? So therefore, uh, first transaction must be committed only after second transaction. Okay. First you commit second transaction, then you commit first transaction. But here first transaction committed and then second transaction. So therefore, that is also bad. Right. So therefore, I'll go for C because though there is no rollback, but it follows the correct sequence. Because there's a dirty read by second transaction, the second transaction commit after first. This is the only place that sequence is preserved. Okay, so then if C1 has issue, you can cascade rollback C2 also. So C2 is rollback because C1 is rollback because C2 has read a dirty value. I'll go for C. Yes, answer is C. Is it clear? Right? If you do a dirty read, right, make sure you commit only after the transaction that has done the writing is committed. So then if first other one has issue, this one also we can abort or reverse or rollback. Okay, simple theory. Right. So the answer is C. 24. Consider the scenario given below. A data file contains 100,000 records, each with a fixed record length of 100 bytes. Okay, let's write it. Let's draw it. Okay. Data file contains. So this is a tough paper when it comes to time. Okay. Time wise, this is a heavily tough paper, but I don't think this is a difficult paper, but I don't know whether you can do it in 2 hours. Okay. You have MCQ and second paper. So you must be really quick. Okay. Right. Data file contains 100,000 records. Each with fixed record length 100 byte. Stored in an unspanned organization. The block size is 2048 byte. A single level index is created on a non-ordering key field. Non-ordering key field. Like non-ordering key field. Secondary index. Okay. Right. So that means the data file is not sorted according to that field. That is why we say but it doesn't say it's a secondary index, right? The single level index is created on a non-ordering key field. Okay.
So it has to be clustering index, isn't it?
Then why do they say key field? Okay. So what is the connection between saying key field? So therefore I'm a little bit confused about the words. Okay. Maybe they refer to key as the index file's key value. Okay. I don't know. Anyway, let's read it. Maybe that's not relevant for us. Okay. Non-ordering key fields, but this is the suspicious word. V, where the size of V is 20 byte. Now let's draw the index file. This field is 20 byte and the block pointer is 12. That means 20 plus 12, 30, 32 byte. Okay, 32 byte. Uh, Again, the block size must be 2048. Calculate the total number of block access required to perform binary search on the index file and retrieve record using this index. That means +1 also you need to consider, right? Binary search on index file and receive the record. That means one more because here you get the block number. Right, so let's calculate the block factor here. Right, forget about the other things. So block factor for here, BFR. That is number of records per block. That will be 2048 byte divided by 32 byte. That will give you how many records in a block. Okay.
64.
Any question? No. Right. 2048 byte divided by 32 bytes. that is 64 records in a block, right? So we can have 64 records in a block. Then how many blocks we need? That we need to determine by how many, because there's no unique value and blah, blah, blah. So then you need to calculate how many blocks we need, because we can say one block, one record per block, but that is if it is clustering index. Now I am wondering whether this is a clustering index or secondary index. Okay, it looks like clustering index.
So I think it is a secondary index because it's in non-ordering. So it has to be dense index. So
Non-ordering key field. So that, yeah, if it is non-ordering, that means your base, your master file is not ordered on that, right? Yes. So maybe then what they mean by key field is here the field and pointer, right? Maybe they refer to it as key and value. Okay, I don't know. That is a confusing thing. Yeah, because it says non-ordering field. That means in the master file it is not ordered. So that in that case it must be a secondary index. Yes, it must be secondary index. If it is a secondary index, so then you need to have same number of records here, like 1,000, 100,000. So then you don't need to calculate the block factor here, or number of, sorry, block factor and number of blocks, because anyway we need 100,000 records. Right? Yeah, because it's non-ordering. Non-ordering means you can't go for one record per block. So let's assume that, okay, because it says non-ordering. So then, so the how many blocks we need? One block you can have 64, but we have 100,000 records because you can't go for one record per block. So that means number of blocks in the index file is 100,000 divided by 64. And you need to seal it, right? 100,000 divided by 64. 1,562.5 means you need 1,563. Like 1,563. So then we can do a binary search here, because now the the field called V is sorted here. So that means you need to find log 2,563 because we are doing binary search, and plus 1 because and retrieve the record, right? So therefore plus 1, because here you get the block pointer. Now you need to get to that block, right? So this is 2 to the power 10 is 1,024. Then you have 2,048. So this is between bigger than 1,024 but less than 2,048. This is 2 to the power 10. This is 2 to the power 11. So therefore here you need to seal it. So therefore we can take 2 to the power 11, right? 2 to the power 11. So that means 11 plus 1. 11 plus 1 is 12. Let's see whether D is the answer. 24. Yes, answer is D. So that means this is a secondary index. And because the question says non-ordering field, forget about the key. Non-ordering field means it's a secondary index. Because if it is a primary index or clustering index, your data file is ordered in the same field as your index. So then it's either primary index or clustering index. Okay. In that case, you don't need same number of entries here. Either one entry per block, or depends on how many unique values you have. And this is a secondary index. Okay, so that is why we need to take log 2 2048, sorry, log 2 1,563, which is bigger than 1,024 but lesser than 2,044. Therefore, we took it 11 and plus 1 because total number of access, not how many access index 5, right? Total. Right. Answer must be 12, okay? 12. Any questions? Right, 25. So if you have any questions, maybe in the next, before the next class, again tell me, I will again revisit that question, okay? Or any other past papers you can go through. And if there are questions that you can't do, just send me the question number, okay? You can post it to the WhatsApp group or send it to me. What concurrency control problems are demonstrated in the schedule given below? Right. So let's see. So read X, X is change and X is written, and now you read it again. So that means when you read it two times, you get two different results. So inconsistency problem. That is write read problem. Sorry, read problem. Is it read? No, not read, right? Write read, right? When you read it twice, you get different value. Okay, you get different value. So that is incorrect summary problem, right? Or unrepeatable read. Anyway, both are correct. Right? So, but this, anyway, there is no uh, order here, right? We can call it either unrepeatable read, but this is not, they are taking the summary query. It's more unrepeatable read, right? Because in between these two reads, you get two different values. Right? I'll prefer to use unrepeatable read, but this is also not a bad word, but this is not a summary query, okay? But anyway, let's see which question is which demonstrated, yes. Right, so
So I
this,
think there is two problems.
yeah, there are two problems. I'm just checking one answers. I'm now looking for the second one, okay? Right, so this is now this guy has written, and now this guy also write. This guy also write. So it looks like we have that lost update also, right? So this value will be lost by this because this T2 write something, but T1 overwrite it. T1 overwrite it after adding 100. Okay, so therefore it's lost update issue is also there. Okay. Uh,
So I think that read is from T2, so it cannot be lost update, I
read is from,
think. Uh, T1 is read from T2.
sorry.
T1 is reading from T2.
This is again reading, right? Yes.
Yeah.
Yeah,
If
yeah,
it's fresh read, I
yeah,
think it
yeah.
has to be the lost
If
update.
this read is not there, it is lost update. But after writing again, it reads. Right? Then I don't know why this has read it twice. But anyway, because of the second read, now it's reading the correct value. By the way, it's a dirty. It looks like a dirty read. Okay, but anyway, it's not a lost update now because this updated value is read and then added to 100. Okay, added to 100. So therefore, yes, it's not a lost update, right? It's not a lost update because you again read it, right? Not you use this value. So now the updated value is read. So that means that update is reflected, right? Yeah. So then there's no lost update. Okay. Yeah. Then I will take those as wrong answers actually. No lost update. No lost update. No lost update. Okay. Uh, right. So then what happens? What about Y? Y is okay, right? Y is only read only once. Uh, dirty reads. Do we have dirty read?
I think so, sir, because underneath there
This
is
is a
a
dirty
right click,
read,
double
right?
click.
This is written value, and that value you read, right? Yes. So this
The
is
last one
actually,
also. No, that one, right? Sorry. Okay.
yeah, this one is a dirty read because T2 has written, and that value you read. So therefore, yes, dirty read problem is there, right? Dirty read problem is there. So dirty read is there. Okay. So then, should we go for C or D? But I prefer unrepeatable read rather than incorrect summary problem because this is pretty much unrepeatable read, right? So when you read two times, you get two different values. Okay, two different values. Uh, so therefore, anyway, these E's also looks okay, but I'll go for C. Okay, is that the answer? 25. Yes, C. Shall we ask ChatGPT? Exactly. I think that incorrect summary means again you read twice, but you read not a particular record, rather set of records for a report or something. Okay. Anyway, let's double check that. What is the difference between unrepeatable read and incorrect summary problem? Okay. Because both are reading twice, but maybe the context. What is the difference between the unrepeatable read and inconsistent, what is the word using the note? Incorrect summary problem. Uh, these are two classic database concurrency anomalies, and they sound similar at first, but they are not the same problem. Let's separate them clearly. Unrepeatable read. And unrepeatable read happens when a transaction read the same row twice, okay? Another transaction modifies or delete that row. Okay, so that is what happened in our example. That is why I prefer the unrepeatable read. The two reads return two different values, right? Same row, different results. That is why I selected unrepeatable read rather than incorrect summary. Okay, right? Incorrect summary. So this is they have given example also. You are reading the same thing. Okay, again you read the balance. Right. So incorrect summary. A transaction read multiple rows. So why you read multiple rows? In order to prepare a report or something like a summary, right? Summary like a sum, average, and so on. To compute an aggregate like sum and so on. Another transaction update some of these rows, so one or more of these rows, while the summary is being calculated. The final result is internal inconsistency, especially when you first read for one report and second read for the second report. Now these two reports are not consistent, right? So it's pretty much similar problems, but at the same time, slightly two different problems. So unrepeatable read means you read the same record. Here you read set of records, but now the result is different. Okay, due to update or insert, or sometimes even due to delete in between. Right, you can see multiple records are it. Okay, and so that's a very clear. Now I highly recommend you to use more and more ChatGPT. Right, in about 5 years, this world is going to be quite different. Okay. So as IT professionals, you will be spending more time problem coordinating your problems to be solved by AI rather than you write code, rather than you do troubleshoot. So this is the reality. So therefore, prompt engineering is, of course, you must know because you must know the subject. Otherwise, you don't understand what the chat GPT or whatever is saying. But most of the time, when you have any issue, when you have any uh, troubleshooting steps, you can quickly ask and you can just do it. Okay. But you must know what you are doing. Right. Right. So that's it about
So I have a
2000.
doubt.
Yes.
In read-write conflict, insert is phantom problem. Does delete also phantom problem?
Delete, is it a phantom problem? I have not seen separately mentioned about delete problem. I don't know why, for what reason. That is a good question actually. Update, yeah, delete, insert is considered as phantom, yes. But I have not your UCSC notes or anywhere else I have seen anything mentioning about delete. So I hope because insert is a phantom problem, I think update and delete is taken as inconsistent summary. Okay. Anyway, let's ask that also, maybe, right? Say between two reads and insert is called phantom issue. What about delete a record in between two reads is called? I hope that is not phantom, maybe. Yeah, maybe that is also phantom. No, I think that is, I mean, I'm not sure. Insert between two reads, yes, phantom read. Delete between two reads, what is called, yes. This is still phantom read. Like because it's not related to one record, right? Uh, yeah, because changes in the set of rows returned by query, not just one. Yeah, so anyway, ChatGPT says delete also we can take it as a phantom problem. Okay, deleting a particular row. But you are not specifically looking at that row, rather you are looking at in general, okay? Right, so that's it about 2024 paper, right? 2024 paper. So we'll do the 2022 paper, sorry, 2023 and 22 because now we can do it faster because we have done one paper. Not in because your exam is about 1 month away. We'll do that in your next Sunday class. Okay, Sunday class because Sunday class morning we have more time. So in the morning session, I will discuss 2023 and 2022 MCQ papers. Okay, right. So we'll stop at this point, right? Thank you.
Thank you, sir.
Okay, you're welcome.